All right, so can you guys tell me, so you were saying you were doing the lab, what lab? 3, let me see, 352. In a 352? 352 is a lab that should be done on the equipment. So you were doing it in Packet Tracer?
Yeah.
And what is the problem? So we were were we doing this lab last time?
Yeah.
Challenge VLAN, right. Oh yeah, we were doing that. So has anyone, that's a good question actually, has anyone completed that Packet Tracer activity and got 100% maybe? No. Okay. So you're saying you were trying to do it, but you got up to 70%.
74.
74%.
Yeah. And I checked the things you showed me, it could be wrong, right? And then actually, I saw something like, because the first species is from IP address. But actually, when I read the last part of that, you know,
Right, yeah, the IP address should be changed at the end.
Yeah, at the end, yeah. So I got confused. Because if I change that, I got to the part in the between. And then, you know, I get confused.
Okay, you know what, we can look at that if you have the file here. If you can share it with me on your USB or email it to me. You. Can you resend it again? And then we have a question from Todd, who is online. Lab assignment for Chapter 3. So lab assignments for Chapter 3. Let me share my desktop. So Todd, you are referring to let's see, you're referring to the lab 352. So 352. And what is the question regarding this lab 352? Do you need to apply port security, or I don't quite follow? For the lab 352. So for the lab 352 that you are doing in Packet Tracer, you are not getting 100%. Is that the question? Okay. Can you email me that Packet Tracer file and I will have a look at it? But regarding the requirements for Chapter 3 for this face-to-face class, the lab 352 should be done on NetLab. Sorry, no, take that back. So that lab should be done in on the equipment here. But that's my preference. But if you cannot make it or try it out, then okay, packet tracer is fine as well. So feel free to send me the packet tracer file and I will have a look. Anything else? Any other questions? So are you guys emailing me the file? Alright, so I will start with a review, and then when I get your file, we can have a look at it together. So I'm going to stop sharing my desktop. So let's do a review of VLAN. So then we haven't finished with all the topics from Chapter 3. So we'll wrap up with Chapter 3, and then we'll move on to Chapter 4. So I would say Chapter 4 is not that difficult. So, but prepare for Chapter 5. Chapter 5 is a spanning tree, and I would say this is one of the most difficult chapters in CCNA 3. So VLANs. What is your first association? What are VLANs? Virtual LANs. You can imagine them as what? One broadcast domain or one broadcast domain, one subnet. So what does that exactly mean? That one VLAN is one broadcast domain. So let's say you have a switch and you have two VLANs on that switch. Let's say VLAN 1, which is the default, and VLAN 2. So let's say PC 2 sends a broadcast frame. So broadcast frame will have in the destination MAC address field, you'll have all ifs. So that's a broadcast frame. So can you tell me who will receive that broadcast frame based on my topology? Only devices on VLAN 2. So VLAN will contain that broadcast. It would be the same if you had another switch connected to it. And you have same VLANs on the other switch, so VLAN 2 and VLAN 1. If PC2 sends that broadcast frame, the broadcast frame will be received by devices connected to this, let's call this switch 1, and this is switch 2. So devices in VLAN 2 connected to switch 2. So let's say this is going to be PC4. So PC4 and PC5 are going to receive that broadcast frame sent by PC2. 2, because they are in the same VLAN. Even though they are on another switch, they are still in the same VLAN. Now, a couple of questions. What type of link between those two switches should be? Yeah, very good. So this is trunk. So this is a trunk link. So trunk link, a property of trunk link is that it carries multiple traffic from multiple VLAN. So in my example, this trunk link is going to carry traffic from VLAN 2 and from VLAN 1. Now, how many VLANs you have on a switch by default? So when switch boots up, how many VLANs you have on that switch? One VLAN? You have definitely VLAN 1. Right, but you do not have only one VLAN. You have all the default VLANs. And these are VLAN 1, VLAN 1000, and you were saying? I think it starts from 3 to 5. Altogether you have, or it starts from 2. 1002 to 1005. So altogether you have 5 VLANs by default on the switch. Now all the ports on the switch by default are members of VLAN 1. So to start with the non-default VLANs, you need to first create a VLAN. You create a VLAN in global configuration mode by simply typing VLAN number. And you can, or you could, but you don't have to assign the name to that VLAN. And step 2 is assign some ports to that VLAN. So let me quickly show you that. So my 2960 switch just booted up. And to look at the VLANs, I will type show VLAN. So I have VLAN 1, VLAN 1002, 1003, 4, and 5. All the ports are in VLAN 1. So if I want to create my own VLAN, so I'll start from the global configuration mode, VLAN, let's say 2. And optionally, I can assign name. Now, even though I created VLAN, ports are still not members of that VLAN. So as you can see, I do not have any ports members of that VLAN. So how do I assign ports to be members of the VLAN? You need to get into the port configuration mode. So let's say interface F80/2, switch port, mode access, and then switch port access VLAN 2. Show VLAN, and now it shows me my port, passed in as port 0/2 is member of VLAN 2. Alright. Now I will add one more switch. I will be connecting those two switches, let's say on the gigabit interfaces. And you told me that this link between switches should be a trunk link. If I want that trunk to carry, if I want that link to carry traffic from multiple VLANs, not just VLAN 1. So I would need to configure both ends of the trunk link, so on switch 0 and on switch 1, with configuration, with a trunk configuration. So I picked the interface gigabit 1/1, right? And what is the command to configure trunk? Switchport mode trunk. Save. So this is switch 0. And I'm going to do the same thing on a switch 1. Switch port mode trunk. Now, how do you look at the trunk information? Show interface trunk. Here we go. So, what does it mean 802.1q? It is a protocol used on a trunk. So let's go back to my where is okay, so here we go. So the trunk, when the frames are crossing from different VLANs, when the frames are crossing this trunk link, the trunk port will encapsulate the original frame using 802.1q encapsulation. So that encapsulation is often called trunking, or sorry, it's often called tagging, because it that port. So in this example, this port here will add that tag that contains the VLAN number into the original frame. And so let's say, in my example, let's say that this PC here in VLAN 2 sends traffic to this PC here in VLAN 2. So I'm going to label them, let's say, PCA and PCB. So as that frame crosses this trunk, the trunk port adds a tag into the original frame header, and that tag contains this VLAN number. So as this port sends it out and adds this tag, the receiving trunk port, reads the tag and removes the tag, and then delivers that original frame to PCB in VLAN 2. So that mechanism that performs this tagging is called 802.1q. It's IEEE standard. So IEEE standard. And again, it happens only on the trunk link. Now let's go back and look at my packet tracer again. So I was doing show interface trunk. So show interface trunk tells me that trunk has been enabled on gigabit 1/1. It's using 802.1q encapsulation, and that native VLAN is VLAN 1. So my question, what is VLAN? What is native VLAN? Native VLAN. Right. So very good. So it does not. So the native VLAN is feature of a trunk, and let's go back. And the native VLAN is the VLAN that's not going to be tagged. So as the traffic crosses this trunk, the traffic from native VLAN, it is not going to be tagged. So we have, let's say, so by default, native VLAN is VLAN 1. So if device, let's say PCA, in VLAN 1 sends a packet to PCB, that's also in VLAN 1 on another switch. So this frame that goes from A to B, as it crosses this trunk, is not going to have a tag. Why? Because VLAN 1 is native VLAN for this trunk. So that's simply a property of 802.1q protocol, so 802.1q standard. And I mentioned last time that this feature is used now in voice over IP, where the phone, where your PC is connected to your IP phone, and that phone is connected to the switch. So this is your PC here. This is the phone, and this is the switch. So your phone, your PC is connected through the phone that has a small switch built in to the switch. Phone knows how to tag traffic, and phone tags voice traffic so that the switch, when it receives the traffic from the phone, knows it needs to be in a separate VLAN. It can classify that voice over IP traffic from other traffic that's coming from the PC. Now, let's go back to my packet tracer. What am I doing now? Oh no, I would like to share only the packet tracer. And I'm going to show you how to change the native VLAN. So let's say I would like to configure to use VLAN 99 as a native VLAN. Now, I first need to create VLAN 99. So show VLANs. I can see now VLAN 99. I created it. Now, I would like to change for my gigabit interface. I would like to change the native VLAN from VLAN 1 to 99. So switch port, access, VLAN, '99. Oh no, what am I doing? Now switch port, trunk, native. Switch port, trunk, native, VLAN 99. So switch port, trunk, native, VLAN 99. And let me show you again. Show interface trunk. So my native VLAN is now VLAN 99. Now I need to do the same thing on the other end of that trunk. Otherwise, I would be getting native VLAN mismatch errors. So interface, first I need to create VLAN 99. Here you go. So this is the error that you are getting if you don't have, if the both ends of the trunk do not have the same native VLAN. So you're getting a native VLAN mismatch. So I will quickly change the native VLAN. So switch port, trunk, native, VLAN 99. Show interface trunk. So now the other end of the trunk link has a native VLAN 99. So we do change typically native VLAN from VLAN 1 to something else due to security reasons, and in the lab they're actually telling you to do that. The security reasons are beyond the scope of the CCNA. Okay. So let me stop sharing and go back. Now, I did ask you last time, what if you have those two VLANs, let's say VLAN 1 and VLAN 2 on a same switch, switch 1. Is PCA able to communicate with PCB? No. Why not? Because of the VLANs, right. So they are, very good thought, they're in different VLANs, different subnets, right? And you need what for that? Router. So this topology, when you are using external router, is called router on a stick. And in next lecture after that, I'm going to show you how to configure the routing for between VLANs. But typically, nowadays, we are no longer using external router to perform routing between VLANs. Rather, we use what? What's that? So we typically do not use this router on a stick to route between VLANs. Yes, we use a layer 3 switch. So typically nowadays we use a layer 3 switch that will do inter-VLAN routing. So layer 3 switch is capable of doing routing, inter-VLAN routing. Now, layer 3 switches are beyond of the scope of the CCNA. If you want to learn about layer 3 switching, take CCNP Advanced Switching. Here, I will teach you how to use router on a stick to do routing between VLANs. Now, the last thing that we haven't discussed this last time, and these are that's the trunking modes. So trunk can be actually established, trunk between two Cisco switches, right? Can be established automatically. Cisco uses dynamic trunking protocol, DTP, so dynamic trunking protocol that can negotiate the trunk establishment between two switches. Now, I was showing you so far this trunk configuration, switchboard mode trunk. So this command disables dynamic trunking protocol, and there is no negotiations of trunk. So this link, if it has been configured like that, so link between switch 2 and switch 1 has been configured as permanent trunk. No negotiations whatsoever. Now, link between switch 1 and switch 3 uses dynamic trunking protocol. So you can see the trunk is configured slightly different. Switchboard mode, dynamic auto. Now, the dynamic dynamic auto mode, if it has been configured between two Cisco switches, will automatically negotiate a trunk. So as soon as you connect two Cisco switches, they will automatically negotiate a trunk. Now, dynamic trunking protocol is, again, Cisco proprietary, and typically I've seen that people do not like to use it, and most of the trunk configurations I've seen are permanent trunk configurations like that.
What's the downside in using a dynamic trunk connection?
Very good. Yeah, very good question. So what is the downside side of using dynamic trunk? Security. Let me show you. Let me quickly show you what I mean by that.
Dynamic, it could be automatically assigned with different computer or different switch, right?
You can you can have so let's say this is a dynamic auto port, so you can negotiate trunk. You can introduce a rogue switch, so someone can bring in their own switch, which will negotiate the trunk. Someone can bring a tool that can do dynamic trunking protocol negotiations, and it can negotiate and establish a trunk. And you know, trunk carries traffic from all the VLANs. So then that person can turn on Wireshark and start tapping and looking into that traffic.
So it's better to use, for security purposes, it's better to have it set up only as not for static, but not through dynamic,
right? Exactly. Yeah, exactly. So more on that, I definitely cover in CNET advanced switching.
So in UCC, NP.
NP, yeah. Okay, I'm going to share one more time my packet tracer. And show you couple of two more commands. So show interface trunk. That's one command you can use to look at the trunk. Now you can do show interface gigabit 1/1 switchboard. So that command gives you a lot more information about any interface, not just trunk interface. Now in this example, we are looking at the trunk interface because I type in gigabit 1/1, and that's the one I've configured as trunk. So this tells you the administrative and operational mode. So administrative mode could be, you could see it as a dynamic auto, and operational mode could be trunk. So these are two different things, but since I have configured trunk statically, so it's trunk only. It tells you the negotiation of trunking is on. Should not do. Native VLAN, it tells you.
And then negotiation will make it insecure, right?
Right. Negotiation of trunking. It's not on. I disabled it. It tells you the encapsulation, native VLAN, voice VLAN, and whether you are trunking all the VLANs. Now, I don't recall whether they do that or not. You can configure for the trunk to not let through all the VLANs. So you can say, you can restrict, and you can say that only VLAN 1 and VLAN 2 can cross the trunk. No other VLANs. And the command for that, I'm not sure whether they show it here. The command would be the interface command. So switch port trunk. That's a good start, and then you can hit question mark, and you'll see allowed, and then again question mark, VLAN, and then you can specify here what VLANs you will be letting through this trunk. So you can add VLANs, you can say all, you can send it except certain VLANs or none. Let's say I will do VLAN 1, 2. So I restricted only 1 and 2 VLANs to cross this trunk. So show interface switchboard again, and you can see pruning VLANs enabled. So VLAN from why didn't, no, it should show trunking VLANs enabled. Why it's not? Let me double check it one more time. So VLAN 1 and 2 are allowed. And let's say I'm going to add one more VLAN. So switchboard, trunk, allowed, VLAN, and VLAN 99. Let's see what happens now. So show interface switchboard. Oh, this is a bug. It should be showing here, not all. It should be showing here VLAN 1, 2, and 99. This must be a bug. Now, I have a question for you guys. Can you tell me where is VLAN information stored? In VLAN database. Where is VLAN database? In Flash. So show Flash, and this is the file. So this is the file that stores all the VLAN information. Now, if I want to get rid of the configuration on my switch, I need to do two things. First, I need to erase the configuration. So erase startup. And then secondly, I need to do what? I need to delete flash VLAN.dat. So When you're doing that, be careful not to delete the whole flash. So from time to time, I need to do a switch recovery because people erase me the whole flash. And you know what's in flash besides this file. What's in flash? The iOS, the operating system. So when you are deleting VLAN.dat, be careful not to delete the whole flash, rather just this particular file. So delete flash : VLAN.dat. And then, so only after you erase the startup configuration and this VLAN.dat file, you can do reload. And when your switch boots up, it's going to boot up without any configuration. All right? What's that? What is the other way? Right, so we'll talk about VTP today. Alright, so that's what I wanted to show you. So let me see if you have guys send me your, and where's the file? What's that? I did not get the attachment. I got the email, but I have not received the attachment. Okay, so I received packet tracer file from Todd. I'm going to open it, and I'm going to share it. So this is packet tracer file 352. So the one that we have been working on last time. And let me see. So Todd, you are saying I are not getting 100%. Okay. Let's see. 85%. So the way you can double check that is go check results and then select assessment items, and it will tell you what items are incorrect. So on switch 1, okay, so this is a packet tracer thing. VLAN names are not correct. So the packet tracer is just an emulator, and you need to type exactly what they tell you. So VLAN name probably either has been mistyped or has lowercase instead of uppercase. And then ports on switch 2, they say are in dynamic mode. So port 11, 18, and 6. So on switch 2. So let's look at that. So switch 1 VLAN names and switch 2 ports 11, 18, and 6. Switch 2, so I'm going to start with ports. So what do we learn so far? Show interface FA0/6 switch port. Okay. So here's the issue. Administrative mode, it says it's dynamic auto, but currently it's operational mode, so it's working as static access. So I'm thinking that this interface is missing switch port mode access command. Save, and let's repeat the previous command one more time. And do you see the difference? Even the administrative mode previously was dynamic auto, which means it could be negotiating trunks, and we do not want that. So administrative mode, static access. So I'm guessing that's the same issue for interface 11. And what's the last one? I forgot. 18. Right. So let me change that for interface 11. So switch port mode access. So this command will make sure that port can only be access port. No trunking negotiations. And that was case for port 18. So switch port mode access. And save.
You can do that for multiple ports, right? So like 0/1.
For the range, yes. Let's see, switch 3. So actually I think you can even do, so show interface FA0/6. Oh, no. Switch port. So same thing. So show interface FA0/11 switch port, dynamic auto, administrative mode. And I'm guessing same thing for port 18. Right. Now, I will try to do configuration for all 3 ports at the same time, even though they're not consecutive. I think you can use comma 11. Let's see if packet tracer supports this. 18. No. Let's see, what's the syntax? Oh. Comma, and then, oh, okay, FA0/11, comma, FA0/18. Okay, so it works. So it doesn't have to be the consecutive range. So switch port, mode, access, and I configured all 3 ports at the same time. And last thing that was giving us issue was the names, right? VLAN names on switch 1. Let's see what should be the VLAN names. So VLAN 56, all capital letters. VLAN 56. Oh, VLAN 56. Oh, now VLAN 56 management and native. So it should be exactly what they say here. So what I'm gonna do, I'm gonna copy and paste. So VLAN 56 name paste, right? VLAN, let's go back. 30. It should be exactly like this. Name, and I'm going to click paste that. And then next VLAN, VLAN 10, faculty/staff. And the last VLAN is VLAN 20, that should be students. And save. So let's see what is our percentage now? Ooh, 98. So let's check results one more time. So this has been fixed. Okay, there is one more issue, and that's IP address for VLAN 56 on switch 3. So let's see what should be the IP address on switch 3. 192.168.56.13. So let's fix that. Switch 3, right? Switch 3. So that VLAN, VLAN 56 is obviously management VLAN. And the IP address that we are configuring right now is the IP address, what's the 7 mask? Is the IP address that's going to be used to manage this switch, which means when you connect to that switch or you ping that switch, you're going to be using that particular IP address. And here you go. We are now up to 100%. All right. Todd, any questions? No problem. Let me see, did I get... No, nothing else. All right, so I'm going to stop recording. Do you guys have any questions? I'm going to stop recording, and then we'll take a break. And when we come back, so we'll take 15, and when we come back, we will move on to chapter 4. All right? Thank you. All right. So chapter 4 talks about VTP. What is a VTP? VTP is WLAN trunking protocol. So VTP stands for WLAN trunking protocol. And VTP is Cisco proprietary protocol. Now the idea Cisco had with VTP was if you had a large switched network and you had end-to-end VLANs. By end-to-end VLANs, I mean you have, let's say, VLAN 10, 20, and 30 that span across all of your 20 switches that you have. So for you as a network administrator, that would mean you would need to go from switch to switch and create VLAN 10, VLAN 20, VLAN 30, and assign them names optionally. So Cisco created a protocol that would help you with VLAN configuration. So their idea was to allow you to create VLANs on one switch, let's say switch 1, and then that information using VTP and propagate that information using VTP to other switches in your network. So switch, the main switch where you would configure VLANs would be called a VTP server switch. And other switches that would be receiving the information from the VTP server would be VTP clients. Now the VTP messages between server and clients are exchanged exclusively over trunk links. Now let's say you have a switch and you don't want that switch to participate in this server client thing. So you would like to configure a local VLAN. So VLANs that will be only on that switch. I'm going to call it switch 4. So VLANs that would be visible only on the switch 4. You would place this switch in VTP transparent mode. Okay. So there are three modes. There are three VTP modes: VTP server, VTP client, and VTP transparent mode. Okay, so I'm going to show you this in Packet Tracer. Three, or let's say 4 switches connected together through gigabit ports. Why did I pick this one? And their links that are interconnecting those switches configured as trunks. So these are just gigabit ports, so switch port mode trunk, and that's all. So I will do the same thing on all 3 switches. I will simply configure the those links as trunk links. So I will make this switch as VTP server switch, and switch 1 as VTP client, and switch 4 is going to be VTP transparent switch. So to look at VTP configuration, command is show VTP status. So show VTP status tells me that this is a server switch, VTP server switch. Number of existing VLANs is 5. Why the number of existing VLANs is 5? Well, 1, 2, 3, 4, 5, all the default VLANs, right? Now, I'm going to look at switch 1, show VTP status. It's VTP server as well. As a matter of fact, all the switches are server switches. So what does it tell you? It tells you that the default mode for Cisco switch when it boots up, it's VTP server. So my switch 0 is VTP server. I don't have to do anything. But I would like to change switch 1 to VTP client. So what is the command for that? Global configuration command, VTP mode, question mark. So here are the options. Server client transparent. So VTP client. Now switch 3, I would also like to place in VTP client mode. So show VTP status to double check that, and you can see it is client. Now switch 4, I told you I would like to place in VTP transparent mode. So to check that, show VTP status, and it is in transparent. Now, I will start creating VLANs on my switch 0. Switch 0 is VTP server. So as you can see, I only have default VLANs. So I will create VLAN 10, VLAN 20, VLAN 30, and VLAN 40. So based on the theory I just told you, the server switch using VTP messages propagates that information to clients, right? So let's see switch 1. Show VLAN. Okay. Yeah, I still haven't. So it takes some time to update the client switch. Let me repeat the command one more time. Show VLAN. Oh, I still haven't received it. Let's see my switch 3. Still nothing. Okay. It takes some time, and packet tracer has some. What's that?
There's a button to fast forward and give the actual clock to the left. And you go to the right to see power cycle devices.
Oh, fast forward time. Oh, would that work for the real time?
Yeah, it sees the time.
Oh yeah, you're right. Thank you. Well, that's a really cool feature. Oh, I know. I forgot to do one thing, and which is, so for switches to be exchanging VTP messages, they need to be in the same VTP domain. Currently, VTP domain name is null. There is no VTP domain name. So I'm going to create one. Global configuration mode, VTP, question mark, domain. Let's call it syscom. It changed VTP domain from null to syscom. Now clients should pick that up as well, and here we go. They picked it up, and they received the VLANs. So if you do show VLAN, you can see on the VTP client switches my VLAN 10, 20, 30, and 40. Let me double check that on switch 3, show VLAN, and here you go. I can see VLAN 10, 20, 30, and 40. And one more thing, show VTP status. Shows me domain name. So clients, when they had no domain name before. So let me go back. See, they had no domain name, and they picked up domain name from the server. So they went from null to syscom domain name. Okay. Now, what happened to my transparent switch? Do you think I will see VLAN 10, 20, 30, and 40 on the transparent switch? Show VTP status. It's still transparent switch. Okay, I didn't change domain, fair enough. VTP domain, syscom. Show VTP status. It is syscom. But do I see VLAN 10, 20, 30, and 40? No. So as I told you, VTP transparent switch does not participate in VTP. So, but you can see my transparent switch is between the server and the client. And the client is switch 3, and it got VLAN 10, 20, 30, and 40. So that tells you that this transparent switch is forwarding VTP messages, but it's simply ignoring them. But it's forwarding them onto the next switch, right? Now, what if I go on switch 1 and I like to add VLAN 50 on switch 1? So VLAN 50. What does it say? VTP VLAN configuration not allowed when device in client mode. So show VLAN. I have not created a VLAN 50. I cannot create VLAN 50 on switch 1 because switch 1 is a client. Now, can I delete the VLAN? No VLAN 10. No. VTP VLAN configuration not allowed when device in the client mode. Yeah, I'm here. This is a privilege. This is the global configuration mode. No, right on the client, you cannot add, modify, delete, or do anything with the VLANs. You will need to do it from the server. Okay? Now, what about transparent switch? Can I create a VLAN 50 on the transparent switch? Let's see, VLAN 15. Show VLAN. It's there. So I created another VLAN on my transparent switch. Now, did that information propagate to other switches? Let's see, do other switches see VLAN 50? Nope. So what does it tell you? What can you do on a VTP transparent switch? Right, you can create, delete, modify VLANs, but they are only local on that switch. Alright? Now, let's say I have end users and I place them in different VLANs, let's say interface FA0/10. It's going to be member of VLAN 10, and let's say interface 20. I'm going to place in VLAN 20. So show VLAN. I assigned interface on my client switch to VLAN 10, and I assigned interface to VLAN 20. So you can do that on a client switch. You cannot create, modify, or delete VLANs, but you can assign ports to be members of that VLAN. So I'm going to connect those two devices to port 10 and port 20. I'm going to do the same thing for switch 3. I'm going to assign port fast Ethernet 0/10 to be member of VLAN 10 and interface 0/20 to be member of VLAN 20. And I'm gonna connect my PCs to those interfaces. Interface fast Ethernet 0/10 and 0/20. Now, let me show you how would you add another VLAN. So you can add another VLAN to this VTP domain by going on a server switch. So I'm on switch 0, which is a server switch, and there you would configure that VLAN 50. Now, as soon as you do that, let's look at the client. So client now has that VLAN 50. So how does the client learn from the server about this VLAN change? Well, there is something that's called VTP configuration revision number. So you can actually see a VTP configuration revision number is 1 currently. And you can see that switches have the same configuration revision number. One. So as you are doing VLAN changes, the configuration revision number increases. So when the server sends a VTP message, that VTP message will contain the configuration revision number. So when the client receives that VTP message, the first thing it looks is the configuration revision number and compares it with its own. If it's higher, that's the indication to the client switch that there was a change. And it should look into that VTP message to apply that change, to apply the VLAN modification. Now, so let me prove you that that truly happens. So I'm going to add one more VLAN, let's say VLAN 60. Okay. So show VTP status, configuration revision number increased, and it triggered VTP message. So show VTP status on my client switch. It shows me the revision number is now 2, which means my client switch has learned VLAN 60. Does it make sense? Now, administrators do not like to use VTP. So what do? They turn it off by placing switches in VTP transparent mode. And I'm going to show you why you should be careful with VTP. I actually witnessed a network being brought down because of BTP. It was quite some time ago, though, when people were not that experienced. But let me show you. So I decided to bring in a new switch, switch 5. And that switch is not connected currently to my network, and I started playing with that switch. So, I don't know, maybe I change host name. Maybe I play with the VLANs. Maybe I'll look at the interfaces. Try out some trunk configuration. And then, well, I decided I'm going to add this switch to my existing network. Okay? So I connect this switch to an existing network. So now, the wrong cable. Okay, fast forward time. And now, why are suddenly the LEDs where PCs are connected amber? Okay, so let's see what's going on. Show VLANs. Where are my VLANs? I had VLAN 10, 20, 30, 40, 50, 60. Where are they? I have VLAN 55, 66, and 99. Uh-oh. Is that only on the switch 3? Well, let's look it up on server. Huh? My server doesn't have VLAN 10, 20, 30. Oops. What happens with PC3 and PC2? Well, they're connected to fast Ethernet interface 10 and 20. I do not see here interface 10 and 20. Uh-oh. My whole network is gone. So what happened? So it is a server, because you know when you bring up the switch, by default starts as a server. And then secondly, I was playing with the VLANs, and as I was playing with the VLANs, my configuration revision number increased. So my configuration revision number is 3, and in the network, do you remember, configuration revision number was 2. So all the switches, including the existing server, thought that they're getting the better deal because the revision number was higher, and applied that change from that VTP message that had highest configuration revision number. So you should be careful, and even though my switch 5 did not have the domain name was now, it picked up the domain name from existing server, yeah. So
would it be possible to manually change the number to maybe prevent that?
Good thinking. So you cannot manually change the number, but you can reset the configuration revision number by changing the domain name. So for example, VTP domain. Look what happens to the revision. Look what happens to configuration revision number. Okay. Now there is one more way to prevent this from happening besides thinking about and erasing the configuration before you connect the switch to the network. So does anyone have an idea? What would that be? What's that?
The switch was configured before.
Yeah.
So at the first time we configured VTP domain, and we should put the VTP password on it to prevent.
That's answer I was looking for. So if you do one more, let me do show VTP. There is option to configure password for VTP messages that are exchanged between clients and servers. So if you set a password, then switch will not receive, regardless of whether it's client or server, switch will not receive VTP message that has not been authenticated. So to prevent this from happening, you would configure password on switch 0, 1, 3, and 4. And if you had the password on all of the switches, VTP password it is, when you connected switch 5, even with the highest revision number, the message that VTP, or that switch 5, the VTP message that switch 5 would be sending would not have a password and therefore would not be authenticated by the existing switches. And that would have never happened. So let me show you how you configure a password. So global configuration mode, VTP, password. Okay. All right. So let me stop sharing. And let's see what do they have here. Okay. So VTP, again, is proprietary protocol. It is working by default on all Cisco switches. And when Cisco switch boots up, it is automatically, by default, is in VTP server mode. And server switches are only switches where you can do any VLAN change. And server switches propagate information to the VTP clients through the trunk links. If you don't want switch to participate in VTP, you will place the switch in VTP transparent mode. In that case, you still can configure VLANs on that transparent switch, but those VLANs will be local, will not be propagated through the VTP domain. And now you know why it's a good idea to configure VTP passwords. One more VTP feature that I would like to show you is VTP pruning. Now let's say you have 3 switches, 1 client and 1 server and 2 clients. And let's say, so this is a server, S1, S2, S3, and these are trunk links, okay? Let's say on server switch you configure VLAN 10 and VLAN 20. Let's say that on switch 2 you only have clients in VLAN 10. No, right, in VLAN 10. And let's say on switch 3 you only have clients, so PCs, in VLAN 20. Now when you show run, or show VLAN, you will see on switch 2 and switch 3 both VLANs, VLAN 10 and VLAN 20. But you only have, on switch 2 you only have clients in VLAN 10, and on switch 3 you only have clients from VLAN 20. Now let's say this device here, let's say PCA, for example, sends a broadcast. Can you tell me who will receive that broadcast frame? So the PCA in VLAN 20 sends a broadcast. All VLAN 20, so it's going to be sent out here. So this frame that is sent by PCA, this is PCA, is going to be sent out here. Is it going to be sent out here? Yes, this is a trunk. Because I told you before the break, by default trunk, so these are trunk links between switches. By default, trunks forwards traffic from all the VLANs. So
because it assumes that an another switch might be hosting a
Exactly. Might be hosting VLAN 20. Yeah. So switch 1 doesn't have ports in VLAN 20. But it has another trunk interface. Does it send out that broadcast frame through that trunk interface? It does. If you have a default trunk configuration, it does, because trunk, again, will carry traffic from all the VLANs. And that traffic will end up at switch 2. Switch 2 will see, oh, that's for VLAN 20, and I don't have any ports in VLAN 20, so I don't know what to do with that traffic. I'm going to drop it.
Isn't that very insecure? Because it's just going to send it out to all these ports.
It will send it out through all the ports in VLAN 20 and trunk ports. It's not going to send it out through ports that are members of VLAN 10.
No, I understand that, but I mean, just the fact that it's getting to the switches, if you have a rogue switch, I mean, that's
True. Yeah, that's why you should allow only certain VLANs to cross that trunk, and B, enable feature that's called VTP pruning. They'll figure out, this feature will figure out, oh, switch 2 does not have any clients in VLAN 20, therefore I do not need to send traffic from VLAN 20 to switch 2. Okay, so it would be the same for the switch 1. So the VTP pruning will be configured on all 3 switches. And they'll figure out what switches do not have clients in VLAN 20 and therefore are not going to be receiving traffic from VLAN 20. Alright, so how do you configure VTP pruning? Well, the global configuration modes. So let me show you. Say on a server switch, VTP the packet tracer doesn't support pruning. Right. I cannot show you that on a packet tracer. So it's simply VTP pruning. VTP pruning, right. Packet tracer doesn't support it. Alright. Any questions? So,
If I use another feature and the tracer gets VLAN at the same name of the VLAN on the other side from the system feature, and I assign support for the test VLAN and connect the PC on that floor, they can connect each other, they can tune and can do that.
yeah.
But we can make.
Same number. Number is what. Yeah, they will talk. So Cisco switch, non-Cisco switch, trunk between them. Same VLAN, same VLAN. They will talk to each other because the trunk is IEEE standard. The non-Cisco switch will just be ignoring VTP messages if your Cisco switch is sending them.
And actually, I just trunk status, but he does the VTP.
Right. Yeah.
So would it be able to forward it to another switch down the line?
That's a good question. I believe it will be forwarding VTP messages. Non-Cisco. So if you have Cisco switch connected to non-Cisco switch, And again, Cisco switch connected to non-Cisco switch. Yeah. I believe it will be forwarded. The VTP messages will be forwarded. So that's non-Cisco switch in the middle is going to be simply ignoring that and forwarding it further. So what a lot of people it confuses them, and a common misconception is that VTP carries information about the ports. So VTP carries information only about the VLANs. You still need to go from switch to switch. So if you have, what did I say at the beginning, 20 switches in your network, and you do use VTP to propagate your VLANs through all the across 20 switches, you still need to go from switch to switch and assign ports to those VLANs. Right, you cannot do it from the server. So VTP does not do that. VTP only propagates VLAN information. All right. So I will, do you guys have any questions? Let me see the lab for this chapter. Yeah, there are 5 labs. I wouldn't say that it's the VTP is that difficult. But next chapter, chapter 5, I would highly encourage you to read it in advance. So that's the typical, so the spanning tree, and that's a typical chapter that people have most issues with. So it's one of the most difficult chapters in CNET 3. Alright? So if you guys don't have any questions, I'm going to stop recording.